the recording, and then Obsidian for the geeky note takers in the room. It's a cool markdown note taking thing. So another link there. Okay. I'm making my promise about talking a lot. So some admin about some upcoming sessions. These do happen every Tuesday, 3 p.m. PST. I am building a question bank. These sessions are for you. I want to make them as relevant to you as possible. So if you're studying during the week or you have an interview and you have a really good question that sort of challenged you, I would love to hear it and present it in the group. So I'm posting in the chat now a link to just a Google form where you can fill in your questions that you come across. Ideally, I would like there to be access to solutions so that people working on them at home can learn from them. So that is sort of a soft requirement. But yeah, please share your questions to help me build this question bank to bring to the group. I have another Q&A session scheduled for the end of this month, TBD. And that's an opportunity to ask someone in the industry who's been in the industry for a really long time to give their perspective on interviewing and tips. So that will happen at the end of the session. And then I've also just put a question out here for you to ponder. I might discuss this further in the Slack group, but been thinking about having informal study group sessions. I'm not sure if Taylor Stanley's on this call right now, but Taylor hosted some informal groups over the break, and they're an opportunity where they're not curated like these sessions, but you can just come and sit with other people and like a college style study group, just work on problems together and discuss. So if anyone is interested in that, I'm happy to open up another day, a Thursday or something like that, weekly, just to have a space to meet. So I'll post that in the Slack if anyone's interested, but just have a think about. Okay. These are the topics that we cover. We don't cover them all every week, but just to give you familiar, these are usually the topics that are covered in most data-related interviews. Okay, at this point, I'm going to have a quick pause. Does anybody have any questions, comments, concerns? Nope. Okay, feel free to keep posting in the Slack. Someone might know the answer. Okay, so today we're going to work on a SQL question, a sort of statistics coding question, and a modeling question. Okay, I'd like to start with an easier one, I'll say, or sort of a short one. So it's a nice conceptual SQL problem today. So if we don't have any problems, I'm going to introduce the first question, and then we'll get into our breakout groups. Okay. So question number one is, what is the difference between a table and a view? And then the follow-up to that is, what is the benefit of using a view over a table? And this is in relation to SQL schemas and databases. So for this question, when I go into breakout rooms, discuss as a group. Some of you, none of you might know, some of you might know, have a guess if none of you know, but see if you can formulate a solution together. And again, practice speaking as if you're in an interview. How would you describe this question? Does anybody have any clarifying questions or follow-ups on this one? Nope. Okay. In which case, I'm going to send you into breakout rooms for about 5 minutes to have a chat together. Okay. All right. See you in about 5 minutes.
how you physically, hi. I think a table is like a collection, so the data is actually has the relations, whereas a view, they don't necessarily have relations to each other.
That makes sense. Maybe those small, where there is table themselves, but they don't have data, or we cannot operate combine or do any operation on them. Like when we are doing SQL, we cannot maybe pull information using them, but they contain, I don't know.
So
This is
just the word view to me implies like is the distinction being made between like looking at an object that can be edited versus um, just
oh,
um, looking at some other object. I'm thinking like, is it like the difference between a copy and a view of
Hmm.
data where you like duplicate the data and you make a totally new thing that you can edit without affecting the original, whereas a view, if you edit that, you've messed up the original as well.
I thought it was the
There's
opposite.
Yeah, I think one of the benefits is that you're saving memory. You're not actually loading data. It's more of a virtual view of a table. So you're not like creating a new table to look at stuff. You're just peering into a table.
Right, cool. Thank you.
I'm just popping in to see how you're going. Looks like going well in here. Got some good explanations going. Has everyone had a chance to have a go at speaking?
Mostly.
Good. Well, we're going to rejoin in 1 minute. So if anyone does want to have another turn at speaking, then go for it.
Thank you, Liana.
That minimizing the IO read?
No, I don't think so, right? Because it's underneath, so it's still going in and then querying all the tables. So all that it's doing is it's giving you a simplified view of the data underneath, right? So that's all actually like it's do, right? So it doesn't really, change the performance or anything like that, right? It doesn't really do anything at all.
Okay. Yeah, I was looking in terms of performance as well, if there is an advantage on view.
I don't think so. Yeah. I don't think there's any performance advantage. It just makes your life easier. So that's all, right? So that is my.
So what about in terms of schema? Schema also, I think both tables and view, they share the same schema, right?
Yeah.
So appropriate tables relating them all together. Then you can trust your views to be, relating to that ground truth, that data warehouse or database, but purposefully built for that department. So I can really see the benefits of that. So you're not creating redundant data from that. At that point. You're not creating a new table. You're using just the view to query that original table or tables, depending on the joins they're doing. Does that kind of sound on point, Liana?
Leia, I think you are unassigned for that session. Did you make it into a group? I noticed.
Yeah, I could do it. Yeah.
Okay.
It was late actually, but it's okay next time.
I apologize. I will.
No problem. I didn't know that how to
join. I also accidentally bailed on a group right as someone said something to me. So I apologize for that. Can't see where they are. It was Joseph. Sorry, Joseph. You said something to me right as the room exited. So.
Oh yeah, I mean, I saw you pop in the corner there, and I was like, "Did that sound about right to you?" And I'm sure we'll get some feedback here pretty soon. But
Yeah. Am I still share screen? Can I get someone's thumbs up that I'm still share screen? No. Okay. Thank you. Yes. So I was just popping into the groups, not to make sure that you're getting the answer right, but just to make sure that discussion was happening and we didn't have any rooms of crickets. And everyone was having pretty good discussions from what I heard. Sounds like everyone was pretty much not on the right track, pretty much exactly on track. So let's, just because from what I was hearing in the group, sound like everyone was saying very similar things. And just in the interest of time, I'll go through the solution for this one and feel free to comment or add if I've missed something in this too, because I did hear some things. So, well, it's a lot of text. I quoted here because this was just a really nice, succinct definition of a view. A view in a database, a view is the result set of a stored query on the data, which the database users can query just as they would in a persistent database collection object. So in other words, we can think of the view as the result of a particular query in simple sense, and we'll expand on that. A table is a part of the physical schema of the database. In a relational star schema database, a table will be either a fact or dimension table, but I think the concept of a table is a little more easier to understand. It's an actual structured table that is stored in the database and physically there. So benefits of using a view over a table. I had some good discussions on this one. Here are a couple. So it represents a subset of the data contained in the table. So that's actually just a fact rather than a benefit necessarily, but I'll expand on that. It limits exposure of the entire table to the outside world. So for example, if you have in a particular company, employees can only access a particular portion of the data set, views are good to use in that way to limit that exposure. If you've got multiple tables, if you've got a big complex query that is joining, maybe 3 or 4 tables, you can actually simplify those complex tables into a single view. So it's easier to query ongoing because you can actually query a view. It can also act as aggregate tables, sums, averages, that kind of thing. So again, simplifying a data set. And then again, I heard a few people talking about this. It is actually, it's virtual. So it takes very little space to store. Views don't actually copy all of the data that it represents. The database just stores a definition of the view. So you can think of it, it's only storing the query constraints itself rather than all of the data from the corresponding table. So it's much more efficient.
Does that mean that you have to do computations every time you call a view? So like the sum and average, does it have to go back through those computations each time?
What's that?
Materialized view is persistent.
My husband just said the materialized view is persistent because I actually wasn't sure on that one. Can you expand on that? Sorry, I'm actually not sure on that one.
So I'm pretty sure a view is evaluated when you call upon the view, so it's executing the query.
Right.
Whereas a materialized view is something similar to a physical table.
Right.
But it's like saved, persistent.
Right. Okay.
I think.
Not sure if you had that. Does anybody? He's my Google on the side here.
Sounds like something you asked the interviewer to stump them back.
yeah. There you go. Interview tip 101. Yeah, good question. I hadn't actually thought of that part of it. Does anybody else want to expand on that, or did you have any other points of benefits to views that I haven't mentioned?
I have a question though. So whenever we create a view, does it it creates a temporary table, but so when we reuse it for another query sometime later, does it rerun the view code again, or does it just use the stored information as results?
Yeah, I think that's sort of similar to what you were speaking to, Robert, by the sounds. So I believe short answer is no. It sounds like it is actually running it again because it's just storing the query. So it would actually have to go through the computation again.
That's why you use a materialized view.
That's why you use a materialized view, because it will actually cache it.
Okay, makes sense.
I do have some follow-ups on this. So takeaways for this particular question. I actually got, this is a question that I got in real life in an interview. And at the time, I actually didn't know what a view was. So it was actually a good opportunity to have a discussion with the interviewer and admit, actually, I'm not too familiar with that. And then he sort of gave me a hint and was able to sort of extract from that. So it was a good practice of learning on the spot. But the reason why they're asking you, they're trying to test your knowledge of SQL database concepts, familiarity with that. Also having the ability to discuss trade-offs and know how and when to simplify queries. Because this is a real life question, the solution is just going to be stored in these slides. So again, join the Slack group so you can access the solutions. Wikipedia is always to the rescue here. I found a good article to expand on these concepts a little more. And then there's another link here for more on database design stuff as well. Cool. All right, well, I'm going to move on to question 2. Please feel free to continue discussion on these problems in the Slack, or if you have more to add. Okay, question number 2 is a coding question on statistics. So I don't believe you need an account to be able to access this. Really hope I'm not wrong about that, but I'm going to post in the chat now this next question because it has a coding editor that you can use. So I've just posted it to the Slack now, but we'll have a look at it together as a group. Okay, so this is from a site called Confetti AI. They have, it's a pretty cool resource actually, lots of different questions, math, statistic, machine learning, and multiple choice questions, coding questions. So really awesome resource. This one, okay, so here's the question in yellow. Imagine that you are building, let's get some Zoom going. Imagine that you are building a service that must process a stream of data regarding inference latencies of a model. It is common to compute summary statistics regarding a collection of data, including its P50 and P90, that is the 50th and 90th percentiles. The cutoff values in the upper 50th and upper 90th percentiles, respectively. We want to implement functions to compute these values for a collection of data. Okay, so they give you the test latencies, just a list of numbers, and then they want you to fill in 2 definitions for P50 and P90. A little hint, you don't have to be restricted to these 2 definitions. You can create as many functions as you like to help you with this task. As you can imagine, these functions will probably be pretty similar. And then you can test code to use print statements, that kind of thing, to test your code. You don't have to submit, you can just test it because you're going to be working as a group. So I am going to put you into breakout rooms, same sort of deal. I'll give you about 7 minutes. And then I'll pop in, see how you're going. Once again, I really want to try and avoid one person silently staring at the screen typing and everyone else is silent while they're trying to figure out the problem. So again, pretend you're in an interview, explain your solution, talk through the algorithm in plain English rather than actually coding it out. Pseudocode is fine if you don't know the correct syntax or functions or whatever. Pseudocode is fine, something that is going to generally sum up your algorithm, give everyone a chance to have some input.
Sorry, question. What happens if there's like an even number of data points and you don't have like a specific 50th percentile value? Do you take the median in that case and take the average or like the 2 closest values?
So it's a really good point, and that is a good clarifying question actually, because there are different definitions of percentile. Some people say greater than, some people say greater than or equal than, some people do interpolation, so some people do median. So I'm going to leave that up to you in your groups to choose your definition. I've chosen one for the solution, so my solution might be different to yours, but there are different ways to implement this. So I want you guys to sort of make a judgment call. The only information we're really given is that the cutoff values for the upper 50 and 90th. So that's kind of making me feel like it's inclusive, but I'll let you debate that amongst yourselves.
Another clarifying question about this. They use the word stream up there, but they give a fixed size array. Are we to interpret this as you want some kind of online computation where it can take a few new values and then recompute quickly? Or
Yeah.
are we trying to solve this problem once for the data written?
That is a good question, and I had a similar thought that when I first approached this problem, okay, we've got to make this a dynamic function, but just not to give too much away, but the solution and what they ask for at the end when everything is revealed is they're just doing a static function that does it for a finite list. So, and I think also just for time constraints, we'll just do the finite scenario.
It is a harder problem otherwise.
It is, yes. And follow-up problem for anyone who wants to do that. Okay, Eric did just ask about normal Gaussian distribution. Again, that can be part of your discussion as a group because that can be part of your approaches of how you implement the percentiles. So I'll let you discuss. I will say you don't need to think about distribution to get a solution out. Just put that out there. Okay. I'll make sure, I hope everyone has access to the question. Hit me up if you don't, but I'm going to start breakout room.
I do not actually see on the Slack. I don't know how I'm missing
the question.
Can you post it on the chat here?
I'll put it in the chat again.
Yeah, I do not see question.
Okay.
Okay, thank you.
In the chat again. And thanks, Joseph. Okay. Groups. Let's do it. Okay. We'll see you shortly.
Just
I thought I clicked.
Cool. I think we're all back. Okay, sorry if I didn't make it to your breakout room in that session. Okay, I just wanted to share this Slack with you just to show you there's the solutions channel for this particular problem because it is a coding one. It's usually many different ways people code it. Please share your solutions in this channel. Even if it's not finished, someone else might be, if you're stuck, someone else might be able to help you or finish it for you, or just sort of see where you're trying to go with it. So please share. It's always cool to see what other people are doing. In the interest of time, I don't think we'll be able to live code it together, but we can go through the solution together, that just sort of from my slides. So again, please pop up at the end if you do want to sort of note something interesting that your group found. Okay, so for this particular solution, because we had to calculate two different percentiles, I thought best just to create a generalized percentile function that creates finds the percentile for any input. So I created this generalized compute percentile function with latencies in a given percentile, 50, 90, whatever. First thing, probably the most important step of this problem is sorting the list. Percentiles is based on order. So sorting it is really important for this particular problem. Then we need to locate the index. So if we're dealing with a Python list, we're obviously going to probably get our cutoff value by referencing its relevant index. Sometimes people refer to it as rank when we're talking about percentiles. Now, I've done -1. You might see some algorithms that are +1. I think depending on your situation, one thing we have to keep in mind is that indexing in Python does start from 0, so we do need to account for that as to what we're going to set as our index. And then to find the percentile, we're going to multiply by whatever percentile we're trying to find. Now, if we have odd length lists, then it's a much easier problem because we're actually going to have, I said midpoint, but it's not so much midpoint if we're doing a non-50 percentile, but we're going to have an exact integer index that we can plug in straight away. So that makes the problem much easier. And if it's an even length list, then we're going to need to find some sort of upper lower bound. So I calculated the floor and the ceiling to get that upper and lower index bound. And then I decided to do this check where if those upper and lower bounds are the same, that means we've probably got an odd length list. It's the single index, so we can actually just return straight away the value at that index that is equal. But if they're not equal, then that means we've got an even length list and we need to interpolate to get the percentile value. Again, a few ways you can implement this algorithm. One particular way is to grab the value at the lower index in the list and multiply it by the difference between your upper index and the index, the actual index we calculated earlier. So this might be a decimal number in the case of even list. And then we're going to create this other value, where we take the value at the upper index and multiply it by the difference between the index and the lower. And then when we add those two values together, we actually get the value we're looking for. So to follow up on this, once we've got our generalized function, our two compute 50 and 90 functions become really easy. We're actually just calling that generalized function. And then this is your example output from the example that they gave us. So they're going to put in that list that that big long list that they had, and this is the 50th and 90th percentile point. So it should just return these two values. So I have some resources down here that expand on more percentiles and interpolation techniques and different methods for calculating those percentiles that I mentioned earlier. There are different methods for this. And this question is from Confetti. So just some takeaways. An interviewer might ask this to test your understanding of formulas potentially. So percentiles, interpolation, IQR, those sorts of summary statistics. You also want to be able to code them. So if you do know the formula, also know the Python implementation, for example. And then think about how you can make your code reusable. So interviewers do like to see how you're thinking ahead or future-proofing your solution. So you might hard code your initial solution, but just have a discussion about, in the future, I might like to future-proof this by making my generalized function that can allow me to compute any percentile. So that's a good place to sort of shine, to show that you're thinking ahead. So I know I sort of rushed through that one. I do want to get to question 3, but does anybody else want to comment or speak further to any of that? Again, please.
Did anyone actually solve it in that time?
I would kind of hope not. I do want to say that it is sort of my hope that we don't come to final solutions, because I do want the emphasis to be more on the communicating. So I do give the game away at the end with a solution, but don't ever feel pressured to get a final solution. That's not really the purpose here. So, but well done if you did.
Oh, good. I feel a lot better now then.
Yeah, no, definitely don't feel bad, because 5 minutes is not a long time, especially in a group setting. So no pressure at all. Okay, question 3. A little more of a discussion question, as I like to do. All right, so this is a modeling question, and we're going to think about this in a scenario. Imagine you run a pizza franchise and you run into a problem with a lot of no-shows after customers place their order. So you can think they might have an online online ordering platform, or they might be phone call orders or something like that. So what features would you include in a model to try and predict a no-show? So a little more open-ended question in some ways, but does anyone want to have any clarifying questions on that?
So I'm guessing they're placing their orders online.
Could be online, could also be on the phone.
On the phone, okay.
But the business model is that they're served in person rather than accepting delivery at home?
Yes, by the nature of that, no-shows, yeah, would be pickup orders. I wonder how it would change if we did delivery and if it was no-show of the delivery driver. Maybe that's something you could think about as well. Eric?
It could be a no-show of the, like it was an order that that was either phony or, for instance, the other couple weeks ago, someone was banging on my door trying to deliver food, and I hadn't ordered anything. And it turned out that it was a neighbor with an address 1 number off, and for some reason they got the wrong number.
Oh.
And they only found this out like 10 minutes later.
You take the free food, or?
No, I just said I didn't order it.
Well, that's very good. Very honest. Yeah, that's good. And actually keep that in mind in your discussion. If you do think of some of these edge cases, think about how that might change your feature selection. Someone asked, Eric asked, is this for a linear model? Yeah. Have a think about that. What kind of model do we think we are going to be building? If we're trying to predict a no-show, what's our outcome? What's our predictor?
Logistic
regression. So before we move, we had one question. So is it like, do we know at what time of day this happens, or it's like happens all through the day, or anything like that?
So that's definitely going to be part of your discussion and how you would pick these features. So it is an open-ended one. So discuss with the group those kinds of factors. I think I heard someone say something about logistic regression. Can someone generalize that for me as to what type of model we're dealing with?
It's a classification.
Right. Right, so this is going to be a binary classification problem. We're trying to predict, will they show or not show two options. So we want to think about what features might we choose for this model, for this binary classification model that's going to predict that outcome.
Just to clarify, when is the payment done in this setup? Is it done upon order, when somebody places an order, or upon delivery or pickup of the food?
That is a good question that, again, I think I might leave to discussion because that could be included in your feature.
It's completely different. In one case, you're losing money. In another case, you're making money out of nothing. So
Right. And you have different incentives. The customer has different incentives too.
Yeah.
So perhaps that could be a feature. Well, I'm gonna do breakout rooms now because I feel like we're gonna get to too many juicy points, give too many juicy points away. So I hope you all have the question. We're just picking features that are going to predict no or show for pizza orders, online or phone call, and have a discussion with the group to see what some of the concerns might be. So I'm going to recreate so that you're with new people. And I'll see you, have a chat for 5 to 7 minutes, and we'll regroup and chat about it.
Oh, darn. Sometimes Zoom fights my computer. I think it was like in room 6, something like that.
Yeah, are you unassigned? Let me.
Yeah, because it like kicks me out of Zoom and I have to like rejoin.
Yeah, weird. Let me have a look. Put you in 5. Okay, try that. It's 2 of them.
Let's give it one more go before I decide to just give up on this one.
Populated in here.
Yeah, I don't know.
Do I need to reassign you again, or do you still have a?
Let's just give it one more shot. Try and reassign. If it's it was group 5 last time.
Let's try this one.
There we go.
Cool.
think it would have to do with what they actually ordered.
Mm-hmm.
That would be interesting if that ended up like being a case. Like if you order pepperoni, you're gonna make it.
Mm.
But like if you don't, you're not. Yeah.
I liked your point. I know I came in about a minute late, but I liked your point of Well, if you have lots of features, you'll just throw them and the whole kitchen sink at a model, right? Like linear or logistic regressions, depending on what you're aiming for. And you can look at the log odds coefficients basically and kind of see, which one is the most explaining of the variance, I suppose.
Yeah, well, that's a benefit of the logistic regression, but like also just defining what a no-show means. Also, because it could be that someone just picks it up the next day or something, like if they have a problem.
I want my pizza.
Yeah.
Although I think that the time of the order itself would matter. For example, if there's a
And so what else we can?
How's it going in here?
Yeah.
Any thoughts on this one?
Yeah, actually, we are trying to figure out the question also. So we thought of like a payment method and price of the pizza, like how much cost. Maybe after all, or after the order, they came to know about the price. So maybe it's high, so they didn't show up, and that's because of payment method. Like they didn't pay it beforehand, so they didn't come to order.
Yeah, that's good.
Maybe duration.
How with that payment one of payment type, how would you store that in a database table?
Feature.
What sort of data type would it be?
Maybe like a binary, whether it's cash or like electronic.
Yep. So you could have a Boolean column of type, of type. Another Boolean one I was thinking of, sort of to what George said earlier, was before or after. Did they pay?
Yeah, before or after.
So you could have another Boolean column with that as well, and that way you can. That's probably a significant predictor in a way, that there's a lot less pressure to pick it up if you haven't paid for it.
So payment on pickup or payment before, like on ordering. Yeah, it depends on this.
Yeah.
And the duration, we thought of this even if they take a long time for it to prepare. So maybe.
Definitely.
And the address where the pizza shop is located, maybe in some neighborhoods, they're not that safe. So people prefer not to show up there.
Right.
Yeah, and I guess to add up, I guess like a confounding variable, like depending on like demographics, we can look at like
demographics.
Yeah, we can like ask for their address and then maybe compare like income levels in that neighborhood and
Like
see.
zip code.
Right.
Yeah, zip code's a good one, even just for some aggregate features of being able to calculate a rough distance. If they live really far away, less likely to drive all that way. Those sorts of columns as well.
Yeah.
Maybe it depends on reviews. Can we consider even that?
Did you say reviews?
Yeah, reviews.
So if a shop has a 5-star rating, people are more likely to come pick up. Is that the reasoning there, and vice versa?
Yeah, kind of.
But also think about how you're gonna get this data. Like how much overhead is there to collect these features? What's the most minimum feature set you can get at the sort of lowest cost for generating the features? It's another thing to think about.
Can we think of revenue of like customers like in that area? Let's say, for example, we can consider the revenue of the like general customers for that specific brand of pizza, let's say.
Mhm.
For example, for some pizza brands, we see that the customers are coming to are like in a higher, I would say, revenue, and we can like kind of like predict that those like specific brands are not suitable or proper for those like with lower revenue. I don't. I think like say for example McDonald's is good for like lower revenue people, something
Yeah,
like that.
yeah,
So
yeah.
we can consider.
Yeah, and that's sort of thinking about the problem in a different way too, because I think the design of this model is you're one pizza shop, and the pizza shop is wanting a model for predictions for their particular shop. But then on the flip side, you could be a third party consultancy, something that is predicting whether you'll have no shows depending on what pizza shop you are. So that's sort of a alternative way to structure the model as well. Yeah, and that you probably would take in different features depending on those two scenarios. Yeah.
Okay.
I'm gonna jump out and join another group.
Okay.
But probably only gonna have maybe another minute or two. So yeah, good to speak to you all.
Okay. Yeah. Same.
Oops. See if I can figure out how to move rooms.
What do you think? We exhausted all options, Liana.
Done.
And we made ourselves hungry, so can we wrap this up now?
That's fair. If it was a real meetup, I could probably provide pizza at the end of it. But
You should, yes.
But thankfully, the overhead is low for me.
You can do this pizzas, just emojis.
I'm curious, what was the discussion around the payment, the paying before or after? How did we factor that into the feature selection?
I think I would put a big if statement, if payment is done before or after, and have two separate models.
Two separate models?
Two separate models, yeah, because one, if you're paying in advance, then yeah, it's the customer's loss. But if you're paying when you pick it up, it's a business loss.
That's true. You could also just have it as a Boolean feature of payment before, true, false, and that could be a predictor. So your model could learn, are people who pay before or after more likely to no show or not? So you could that could be a one model solution in that way. I heard some people talking about categorical features and payment types and that kind of stuff.
The vegan pizza.
The vegan pizza.
Yep. So you're talking about hours of the day, right?
Yeah, I was saying like maybe people who order at 3 a.m. are more likely or less likely to leave it. Because personally, if I was asked this at an interview, I would just create a model where I would say, personally, I think a bunch of drunk college kids in the middle of the night are most likely to not pick up their order. But I feel like that's kind of, biased.
Maybe you could
I would
have
create a model to fit my bias.
You could have a column that is sobriety status.
Take a test.
How drunk on a scale of 1 to 10 is the customer?
And then somebody had mentioned in the main room also the price of the order. So like I was thinking maybe if it's on either end of the price range, like if somebody puts a $1,000 order, it could be a joke or it could be a very large party. We don't know.
Very true. Very true. Would you store that as a continuous variable or categorical, like have payment brackets, do you think?
I think payment brackets would be easiest.
Yeah.
Also probably take into account the weather. I was just like, when I said that, I was like thinking about myself. If you place an order and then it starts like pouring down, well, chances that people are gonna go and pick up the order are probably less than when actually the weather is nice, or the distance. If they take your address, people who are like live like far away from the pizza place are probably like more likely not to go pick it up than
Yeah.
I don't know. That might be like another factor to take.
Definitely. Definitely. So sort of more environmental factors outside of the customer and the business. Yeah. Yeah, for sure.
Oh, and George brought up if they're new or existing customers too.
Yep. That's
Yeah.
that's stuff that would have to be a predictor. Awesome. I like this is a fun group. I like this. Well, I think it's time
Talked about like pretty much like we consider. I promise you, we consider like pretty much everything.
Everything.
Pretty much
There's something
everything.
I'm sure there's something else that somebody else might have.
That's awesome. Cool. Well, in that case, I'll close the rooms and we'll come back together and have a look together.
All right.
Good to chat with you guys. My husband's playing some heavy metal apparently and having a bit of a in-house mosh pit on his own, so, as you do on a Tuesday afternoon. Awesome. I think I lied about the 5 to 7 minute discussion, but I was really enjoying some of the discussions in the groups. And group 1 exhausted all possible possibilities. So it was time to come back. Getting there. Okay. Are we all back? Just about. I personally really like this problem because I think it can go in a bunch of different directions and it's really makes you think about all those components that go into ordering pizza. So for the solutions for this one, I always do funny ears for these types of questions because there's almost infinite solutions for these types of questions and could be debated all day. So I've got a very small list of features and I definitely heard some being discussed that I hadn't thought of. So again, please share those either in the Slack channel or you can obviously share them right now in the chat as well while people are here. But let's get going. Okay. So I sort of gave a hint at the start about thinking about the high level. For this question, and from what I heard, most people were touching on all three of these. There are kind of three overarching categories, including business, features to do with the business side of things, the actual pizza shop, the customer, features to do with the customer, and then environment. Heard some people talking about the environment as well. And just to clarify this question as well, we're imagining this scenario as the pizza shop is hiring a data scientist to build one model just for them to predict their no-shows, as opposed to another scenario, which some people have been thinking of some predictors in this other scenario, where you might have multiple pizza shops and a sort of a third-party source, maybe evaluating the business success of no-shows or something, in comparing different pizza shops. So that's another scenario, but this particular question is more aligned with that single shop scenario. So let's expand on these to sort of cover some of them. This is not an exhaustive list. So on the business end, you might include things like order method. I heard this a lot. Did they make it a phone call, online, or in person? In person's interesting. That might be the scenario where they order it, it's going to be a 30-minute wait, they walk away, they don't come back. That could be that no-show scenario. Total order cost. I was talking about this with one group in that perhaps you have this as a continuous variable, as an actual float value, or you might have payment brackets. Is it under 20, 20 to 50, over 50, whatever, of total order cost. So you could have it as a categorical variable. Number of items ordered, potentially. Is it a huge order? Is it just one item? projected time to complete the order. So if it is a big order, or if there is huge wait times in a busy period, perhaps people aren't as likely to show. In that scenario, I would be thinking of an online order where the customer can actually see preparation times. If it's phone, maybe they don't know. Pickup or delivery, Robert sort of touched on this scenario. This might be the case where maybe using like an Uber Eats where the delivery driver doesn't show up. How often does that happen? What are the edge cases in that scenario? Definitely more predictors to do with the business side of things. So feel free to share other ones you came up with. On the customer end, if it's a phone call, maybe you can grab their area code. Maybe that has something to do with it. I don't think that would be too accurate because people move, have the same phone number for a long time. So that, might be a bit of an iffy one. I guess the one pro to that is sometimes if you're taking an order on the phone, I'm reminiscing back on when I used to waitress for a Chinese restaurant and take phone orders. You're not always taking down people's address. You don't know where they're located. So maybe an area code can be a rough gauge on that. Zip code, you're most likely going to get a zip code if it's an online order and you're putting in your address. So you might have access to that. Length of time of the calls or time spent on the ordering system. Was it just a quick order that someone might forget about easily, or did they spend more time and think about it more? George mentioned this one, I think, of whether they're a returning customer or not. So just have that as a Boolean column. That would be probably a really good predictor in some ways. Environment, so day of the week, time of day. Are they drunk college students, which was another discussion in another group. Temperature outside was also a discussion I heard. So is it, and the weather type, is it raining? Is it snowing? Is it sunny? How much are those environmental factors coming into this? So on top of this one, if you're in an interview setting, this is a really good opportunity to show off your knowledge about modeling and to also show your interviewer how good you are to work with, how good of a conversationalist are you in a way. So treat these particular problems like a conversation. So these are some other discussion points you could have with your interviewer in a question like this. How are you going to actually acquire the data? I spoke about that with another group. Is there a lot of overhead to accessing some of the features? Maybe you've got some really complex aggregate features or that need to source third-party data or something like that. That's going to have a lot of overhead to actually generate those variables. So you might even think about for your model, what's the smallest feature set that I can have at the lowest overhead, at the lowest cost, that's still going to give me a pretty good model. Is the business benefit actually worth the effort and cost of gathering the data? That's actually a really important question to ask. If it's going to cost a lot of man hours to gather this data, how much is no-shows affecting your, your end cost, your revenue? If it's huge, then it's probably worth generating that data. If it's not significant, probably not even worth building a model. So that's another thing worth noting. And what other modeling concerns are you going to, you might need to be conscious of? So in this scenario, can anyone comment on, would this be a balanced data set or would it be unbalanced? What would we be dealing with in this scenario most likely? You can just unmute.
Hopefully
unbalanced, hopefully, right? You would expect that more people are not showing, less people are not showing up than are actually showing up.
Right. Like Robert said,
Yeah.
hopefully unbalanced. Yeah, it would. You probably don't have a good business model in general if you've got a balanced data set. So most likely unbalanced, so you're going to have to think about how you're going to balance your data set in this model. Perhaps you could discuss how you're going to tune the model, how you're going to update the model as new data is coming in, that kind of thing. So again, these are just sort of extra, maybe brownie points with your interviewer. Again, feel free to share in the chat.
But as the original question was stated, right, it sounds like this is one of those where you're going to have to ask a lot of clarifying questions to your interviewer, right? Absolutely. This is not, you can't just, you're not going to go in and just make assumptions and start talking. I think your interviewer would expect you to start asking for all of these clarifying questions.
Definitely. Yeah, it's definitely a question designed for a chance for you to shine, to show how you are thinking about it. These questions, the reason why interviewers ask these questions are really to get into your mind. How do they think? How do they approach problems? Do they just start word vomiting a list of features and see what sticks? Or are they going through sort of in an analytical approach and thinking about, okay, what makes the most sense as a predictor, and what more information do I need to know in order to choose my features? So this is definitely, actually, I think I said it here. It is a discussion style problem. Remember to ask questions and engage them, and yeah, just they are human. You can discuss with them. So this one, the takeaways for this one was, yeah, just think about variables that are going to explain the predictor, and then some brownie points if you can maybe raise some of the other problems that you might face when building this sort of model. This question was from Interview Query, which I use all the time. It's a great resource. They have, the reason why I like them is because their solutions are really geared towards how you would answer in an interview rather than sort of a analytical answer or a strict answer. So it's a really good resource for that way. They also have some courses on interview prep and that kind of stuff. So it's a good study resource. And then just included some more on binary classification, just because we did sort of touch on that here. So that is all I have for today. Contact details are there if you do want to reach out to me. But
Can you go out really quickly?
Huh? What?
Can you go out?
No, I think that's me. I'm just gonna do that one. This is a time for you. You're welcome to leave now, or you can stick around and chat about interviewer experiences, tips, questions, circle back to questions. This is really just this open discussion space for you.